Lost baggage. The U.S. carriers reporting mishandled baggage data posted a mishandled baggage rate for the first quarter of 2010. The carriers posted a mishandled baggage rate of 4.10 per 1,000 bags handled, down from the 4.39 rate per 1,000 bags for the first quarter of 2009. Use a 5% significance level to test if the drop is a significant reduction. So of course I underlined the phrase "to test" because that tells us it's a hypothesis test we're working with. And it's a hypothesis about the proportion because you notice they're talking about the rate of mishandled bags in this problem. So it's a problem that deals with proportions. So let's write the claim down. From the statement here that it says it's a significant reduction, what they're trying to say is that the mean, or the proportion, pardon me, for 2010 has dropped compared to the proportion of 2009. So in other words, in 2009, they're saying the proportion of mishandled bags was higher. In 2010, it's lower. All right, now, the HO and HA are going to come from the claim. The claim here is a less than symbol. That makes it the same as HA because that's one of HA's symbols, right? So we'll say 2010 less than proportion for 2009. And then, of course, HO expresses the opposite idea. In this case, that will be greater than or equal to. So row 2010 is greater than or equal to row 2009. All right, and then we're going to write the data down. So for 2010 and for 2009. One important thing about this data is they talk about 4.10 per 1,000 bags are mishandled. So they're not giving us an N or an X the way we normally think of it. When we deal with a proportion, we're usually used to having an X and an N, and we divide them and get a P hat. We don't really have that here, but you can treat them as if they're your X and your N, because essentially what they're saying is that the P hat, the sample proportion for 2010, can be found by 4.10 per 1,000. The word per in mathematics means to divide. So if you take 4.10 and divide by 1,000, you will get an estimate of the sample proportion for 2010. For 2009, they have the same kind of information, right? They have 4.39 per 1,000 bags, right? And again, we'll get a sample proportion. So it's a different way to give the same thing that we normally have in problems. But of course, this can't be an X because, X would have to be an integer. It can't be something like 4.10. And, the N here, of course, for these baggage handlers, the airlines, of course, handle a lot more than 1,000 bags in a year, of course, right? So the 5% significance level here can be written as 0.05. Okay, so let's get these numbers. Of course, if you're dividing by 1,000, all you have to do is move the decimal place over 3 places. So you're going to end up with 0.00, then 4, 1. And then this other one will be, of course, 0.00439. So those are the p-hats for the 2 different years. Now from here, we're going to take that information and plug it into our z test stat, right? Our z test stat is going to have the following structure. It's going to be the p-hat for 2010, minus the p-hat for 2009, all over the square root of p-hat times q-hat, which are going to be the pooled estimators of the common proportion that we believe to be in existence in HO, right? So in HO, we have this equality part of HO, and based on that, we're going to assume there might be a pooled proportion that we could create, or at least an estimator of the population proportion, by using this pooled estimator p-hat, right? So we'll have x bar 1 plus x bar 2 over n1 plus n2. So we'll plug that information in to get this p-hat value, and from that value we'll derive the q-hat. So that's where the p-hat and q-hat will come from. We'll just do 1 minus p-hat for that. Okay, and then from there we do 1 over n1 plus 1 over n2. Now in this problem, we're going to treat our n as 1,000 for each of those. Okay, so let's go ahead now and plug in the numbers and see what we get. So we'll have the rate here of 0.0041 minus 0.00439 all over. Let's work out what this p-hat value will be. It'll be, in this case, 4.1 added to 4.39 all over 1,000 plus 1,000. Okay, so that's going to give you 8.49 on top divided by 2,000. So if you do that in your calculator, you get a decimal for it, so you can store it also into your calculator if you're doing that. The answer will be this. So it would be 8.49. That's just adding those two numbers together, right? 8.49 divided by 2,000. And you get this decimal, 0.004245. I'm going to actually store that in my calculator as p, so I can use it later in my calculations, right? Store it in my calculator as p. Now from there, what I'm going to do is, of course, do 1 minus that answer, so that I can end up with my q, and then I'm going to store that again in my calculator as q. Okay, and this will allow me to enter the values into this formula without doing any rounding, right? Okay, so of course this one turns out to be 0.995755. Okay, so we have those values. Now what I'm going to do is just enter them in here. Of course, for this first one, it's 0.004. I'm just going to round, so we save space when we write them. And the other one's 0.996, right? And then we'll have, 1 over 1,000 plus 1 over 1,000. So of course, that's going to be 2 over 1,000. All right, let's plug that one into our calculator and see what we get. So we have on the top the 0.0041 minus 0.00439. Close that up, hit divide by the square root of, and in the square root we're going to have p times q. And again, I've stored that in my calculator, so I can just enter it as p times q, times 2 divided by 1,000. Okay, so now that we have that all in there, we're going to go ahead and hit enter, and we get the answer minus 0.0997. So if I round it off to two places, it's minus 0.10. So minus 0.10. Okay, and at that point, that is our test stat for the problem. So it's a very small test stat, and you can see that essentially that's not going to allow us to reject the null hypothesis. We can just assume at this point that we don't even need a critical value. We're going to say we cannot reject the null hypothesis, therefore we cannot support the alternative hypothesis. But just to be, proper about it, let's go ahead and finish the problem by getting a critical value, show that it doesn't land in the rejection region, this test stat, and then formulate our final conclusion. All right, so getting the critical value requires us to draw a picture, right? And then we look at the HA and we see that it's a left-tailed test, so we're looking for the test stat to land over here in the rejection region in order to be able to reject the null hypothesis. When I look at the alpha here, it's alpha 0.05. That's going to be in one tail, so that's z 0.05. If I look that up on my table, I will find the answer to be negative 1.645. This is a common value. You can find it on the t-table by looking at the 0.05 column and going straight to the bottom. We've done that so many times with the z-charts, both in Stats 1 and in earlier videos in this course, and I'm going to go ahead and just put that answer there for us, and you can check that on your own to confirm. But when you look at this test stat, you can see that this test stat clearly lands here in the white space. It's not in the rejection region, so we're going to say do not reject HO. And because we say do not reject HO, we're going to say then do not support HA. And of course, if you're not supporting HA, you're not supporting the claim, because the claim is the same as HA. So basically we can say there's not sufficient evidence to support the claim. There is not sufficient evidence to support the claim. Okay, and the claim there, of course, is that there's a reduction, a significant reduction in the mishandled baggage rate for the airlines in 2010 when compared to 2009.